The James Webb Space Telescope, JWST, was designed by us to see into the darkest parts of the universe and take pictures of the first galaxies that formed after the Big Bang. Scientists have been able to decipher the mysteries of the early universe thanks to this remarkable piece of technology, which has allowed them to observe cosmic phenomena that were previously hidden from us. However, as we investigate the universe in greater depth, we come across unexpected results that cast doubt on our current understanding of the universe's age, structure, and origin. The JWST was made to notice the main systems that framed in the universe, a period frequently alluded to as the vast first light. This epoch took place just a few 100 million years after the Big Bang. It marked the transition from the so-called Dark Ages, when the universe lacked stars and was filled with neutral hydrogen gas, to the era when galaxies formed. The objective was straightforward but profound: to acquire images of these ancient galaxies and investigate the properties of those galaxies in order to comprehend how the universe progressed from a hot, dense state to the complex structure it is today. However, scientists are perplexed by the JWST data. Galaxies that appear to have formed, been massive, and evolved over the course of the universe's existence have been discovered by this telescope at unexpected times. Astronomers have been forced to reassess our understanding of the early universe as a result of the discovery. Is our understanding of how the universe was created incorrect, or is the data incorrect? The scientific community is interested in this question. JWST perceptions depend on a significant change in perspective. We held the belief for a number of decades that the universe was 13.8 billion years old and that the first galaxies formed approximately 400 million years after the Big Bang. However, JWST images suggest that galaxies existed long before the Big Bang, perhaps 100 million years earlier. This discovery suggests that the processes of galaxy formation are either faster or more efficient than our models predict, and that the universe may be smaller than previously thought. These disclosures are lowering and advise us that notwithstanding our trend-setting innovation and knowledge, we are just starting to expose the universe's secrets. JWST, with its powerful infrared capabilities and golden mirrors, provides a window into the past that was previously inaccessible. However, with each new discovery, more questions are answered, necessitating revisions to our theories and consideration of new perspectives. The detection of galaxies that appear to have formed just 320 million years after the Big Bang is one of the most amazing discoveries made by JWST. Initially, apparently it would require billions of years for a universe like the Smooth Way, with its tremendous assortment of stars, planets, and dull matter, to shape. However, there is evidence that galaxies existed before the universe was even half as old as it is today. Scientists were taken aback and perplexed by this discovery because it challenges the fundamentals of our understanding. In addition to being breathtaking, the JWST images also reveal details that other telescopes are unable to see due to clouds of gas and dust. A 12.5-hour exposure deep-field image of the universe's most distant regions is one of JWST's first images to be released. This picture incorporates the system group SMACS 0723, loaded with large number of universes. Despite being the smallest infrared objects ever observed, some of these galaxies hold the key to understanding the early universe. The galaxy cluster SMACS 0723 is a marvel of cosmic architecture because its enormous mass acts as a magnifying lens, bending and magnifying the light of nearby galaxies. Using a magnifying glass to enhance an image is similar to this effect. Light traveled through the universe for billions of years before reaching the telescope in the deep image taken by JWST, which shows galaxies that date back 4.6 billion years. The Mazy galaxy stands out among the many galaxies in this deep field image. Named after the girl of the stargazer who found it, this world is one of the most established known and offers an uncommon look into the early universe. The image depicts the Mazy galaxy, which was formed when the universe was only 390 million years old. It is a bright orange galaxy. In astronomical terms, this is exceptionally youthful, making the Mazy world one of the 4 most established cosmic systems known to us. Our knowledge of how galaxies form is greatly impacted by this discovery. Astronomers only had a rough idea of how galaxies used to look before JWST. According to the JWST data, the Mazy galaxy is a good illustration of a primordial galaxy with intense star formation, compact size, and brightness. The Mazy Galaxy is smaller than the Milky Way, a large spiral galaxy, and it has more stars but fewer blue stars. The study of ancient galaxies like the Mazy Galaxy has improved our comprehension of the universe's evolution. The age of these galaxies is determined by using a measure called redshift. The term redshift describes how light travels through the universe from far-off galaxies to the red end of the spectrum. The galaxy is older the more redshift it has. The Mazy Galaxy is one of the oldest galaxies ever discovered because its redshift is approximately 13.1 billion years old. Investigating the Mazy system is only the start. JWST has the potential to expand our knowledge of the universe's history and uncover even more distant galaxies. Researchers are forced to reevaluate their models and theories with each new discovery because it raises new questions and presents new obstacles. JWST is more than just a telescope. It is also a time machine that takes us back in time to the beginning of the universe, when galaxies, stars, and possibly life first appeared. NASA announced the discovery of even older galaxies in November 2022, just a few months after the Deep Field image was released. Some of these galaxies were formed 350 million years after the Big Bang.
Telescope
These cosmic systems, distinguished in pictures from JWST's bigger review project, are among the most antiquated at any point noticed, with redshifts of 10.5 and 12.5. The long-held belief that galaxies formed and evolved over billions of years has been cast into doubt by these findings, which have shocked the scientific community. The galaxy known as Glass Z12 is one of the most significant discoveries made during this time period. Just 350 million years after the Big Bang, this galaxy, which holds the record for the farthest observed galaxy, formed. GN-Z11, which formed 400 million years after the Big Bang and had a redshift of 11.1, held the previous record. The discovery of Glass Z12 and other galaxies that are similar to it suggests that the universe's first galaxies formed much earlier than previously thought, which may have brought an end to the dark ages earlier than we had anticipated. These discoveries have significant repercussions. The universe's timeline needs to be reevaluated if galaxies began to form 100 million years after the Big Bang. The so-called dark ages, when there were no stars or galaxies and the universe was full of neutral hydrogen, were shorter than we thought. Additionally, this raises concerns regarding the roles that dark matter and other components play in the processes that lead to the formation of galaxies. New insights into the early universe's formation have been provided by the discovery of these ancient galaxies. As opposed to the turbulent climate we expected, these early universes have all the earmarks of being impeccably requested. This challenges the common belief that the earliest galaxies were chaotic and gradually developed into the galaxies we see today. We still don't know how much order existed in the early universe, as evidenced by JWST's detailed images. One component of the JWST project is the investigation of these ancient galaxies. Dark stars and other universe mysteries are also illuminated by the telescope. The destruction of dark matter, not nuclear fusion like normal stars, is thought to be the source of power for these fictitious objects, which were first proposed in 2007. Dark matter is a mysterious, incomprehensible substance that accounts for 85% of all matter in the universe. The discovery of dark stars in JWST data was made public by researchers in August 2023. These findings will shed new light on the role of dark matter in the early universe if they are confirmed. Not at all like typical stars, which discharge light from atomic combination, dull stars are remembered to gleam with light created by the obliteration of dim matter particles. One of the brightest objects in the early universe, these stars could be millions of times as massive as the Sun and billions of times brighter. The idea of dark stars is fascinating and controversial at the same time. Assuming they exist, these articles would have framed soon after the huge explosion from hydrogen and helium mists that fell before universes shaped. Inside these mists, dull matter particles impact and obliterate one another, delivering energy that warms the encompassing gas.